Hello YouTube, welcome back to the Bison Workshop. I'm Bob, and today we're going to take on another task on the grizzly mill, the g0758, and we're going to do some modifications to it, and we're just in experimenting mode right now. Haven't got anything ironing or chiseled in stone yet, but as everybody remembers, this year was pretty tough to move up and down. Well, of course it's not going to move now because I've got the keyway out of it right now. I just wanted to show you what it looked like before. For starters, this head seems to be awfully heavy for this wheel. So to go up, you had to really crank on it and your fingers would hit the edge of this thing here, and it's got them little fins on the back of it that's pretty sharp. And you catch one of them wrong way, you're going to cut yourself. So to eliminate that from happening, because they've got it just way too close. I mean, you ain't got very much room to put your fingers in between there. This year should have been shifted over here with a gear. But anyway, or power feed. So basically what I did, I just went ahead and took this off, lifted that off. Whoops, don't want to lose that. That's the bearing cap. It's got one of them washers. Well, it's got two washers with a valley in it, and then a cage with bearings in it that lays on the one, and then this one squeezes it, so it's like a sandwich effect. Alright, so I went and made this plate right here, and that was going to mount right there, and it was flush on both sides and flush on the back. Looked pretty decent. And I just took this over after I drilled the biggest drill I got and started boring it out on the 4-jaw chuck. I've got to make another one of these, so you're going to get a chance to see that happening. We hope. It might be too long. I might have to cut it another way. So anyway, that was going to mount there, and I was going to mount this, which I made. This here plastic pulley came off of one of them stand-up motorized scooters, and this was the big one that went onto the wheel or the axle, and I made this aluminum bushing to go in here, and they're threaded, and I used cap screws on this side. And this here, after I find my washer, I put my washer on there to make, not that one, it's another one, it's a thinner one. There it is. Put this thin washer on there, and what that does is creates a way for this to have a gap in it between this casting, because it's really close. So I imagine once you get a little pressure on it, it's going to push it down to where it touches this. And it does have some scratches there on the top where it has been hitting before. So to eliminate that from happening, we just put a little thin washer in it, paper thin, and that will make that part proud of the casting. I was going to take this and mill that off, but I didn't want to mess with that tag. So I just went this route. Alright, so then I made that so that first of all, you see the keyway right there, right? Alright, look at my keyway. What I did, I drilled my center hole, then I went over with an 1/8 inch bit, or whatever it was, the width of my file, which happened to be the same width as the key. So I lucked out. I drilled a hole, and then I filed the rest of it down to the hole. And there's my keyway, and I'll even show you the keyway working so you guys can believe me. Oh, Lord. I think that's going to be the task. Then my washer's got to go on last. I need to find me one that's a different size, that's that thin, and file a groove in it, or keyway. Alright, what's going on? Why won't that go in there now? It's all the way up. Yep. Go down from this side. There we go. Alright. This, slide down on that keyway. And there we have it. So now, we're going to put a nut on it. And we're not going to tighten it now because I got to take it back off. Now we're going to test it. So we're going to unlock our head. Takes a little bit more to bring it up. I'm not real sure that shock is working correctly. Or is that tightening it up? I think that's tightening it up for me. Well, anyway, you guys get the idea. Alright, then I used the motor, which is 24 volt, 135 watt, model MY6812. Alright, so then I was going to put this in here just like that. Alright, and because my belt needed to be higher, I decided to bring it up so that all this belt was parallel with the base that I made. Alright, once you get that belt parallel, then you can pretty much figure how high this motor has to be. So I went ahead and cut me a second piece to go on there to mount like that. But the problem with that is there's not enough gap between the bottom of this pulley and the housing to accommodate for this thick of steel. So I had to scrap that idea. So then I decided, why not take this off, turn it the other way like that, make this plate longer to come out, and it's got spacers right there. So that would be mounted exactly where it needs to be to ride to that pulley. So this plate will come out further, which is the new plate. So now I've got to drill and bore a hole in this. I don't know how I'm going to do that. This is going to be tricky because now we got to go. Alright, now remember, this is a 24 volt motor. So I tried it on 12 volt and it seemed a little weak. It still wouldn't be able to or I couldn't stop it with my hand. So, you know, it had a little power to it. So then I went and hooked it to 24 volt, and it had bukus of power. I mean, it was just flat out wide open, just humming. So I thought, well, why not reduce the voltage and just kind of find what I want to use. So I went in and found an IBM, stamped IBM, power supply for a IBM laptop, an older one. And this thing is rated at output. Let's see, get my magnifying glass here. Well, we know what the AC's input, and the output is 16 volt DC, 4.5 amps. There's where I'm hoping I don't run into too much of a problem, because I would like it to be up there around at least 15 amp, something like that. So I'm debating on this. I did test it with the multimeter, and it's more than no 16 volt. Now, if it had been a 16 volt truly, I probably wouldn't be using it, because it'd probably have it speeded or slowed down too slow. We want to kind of find a happy medium. So when I tested it with the multimeter, it showed 18.8 some volts. Can't remember what the number was. But I'm going to try and use this, and worst comes to worst, I don't have nothing in this. You know, it was probably give to me, and you know, somebody's junk stuff. And what's the worst that can happen? I got to go and buy a 24 volt variable speed converter, if there is a such thing. So I got my switch ready. I got a two-way on, middle off, and this will be my up and down. So we're going to have to make labels or something to put on here for up and down, and we're going to mount this somewhere. And I'm hoping that if this will work, I'm going to test it before I do any configuring the metal to work with it. This will give me a chance to put, you know, use this bracket for more than just a so it'll go in there like that, but it'll be back further than that. So I'll have this overhang back here on the back that I can mount maybe the power supply right here on the back side, or something like that, because remember, the motor's going to be up here. The motor's going to be right here like that. So basically that's the idea. Right there. In a nutshell. Let's move that around to there. So the only reason it's up so high right now is because this piece is under it and it won't be there. It'll be down further. So basically this is what it's going to look like. And then I've got all this underneath here. Of course, I'll trim this and make it look a little neater. And maybe we can get us a little box and put it underneath there somewhere. If this power supply will work, maybe I can just take this thing apart and mount this and the switch in one board. Really wouldn't mount this in another box, because it gets warm enough the way it is. You don't want to push it. In fact, you may even need a fan on it if you was running it a lot. But we would only be running it when we needed to raise and lower the head, and that ain't very often. So that's where we're at. So I guess the next thing we need to do is take this plate off. Take the wheel off. Take the keyway out. Take the plate off. And right there, we have to cut so basically what we got to do is we got to draw that circle. That's the one we got to cut out of it, and then we got to cut this off. And I think I'll just go straight on across. Just like so. So I'll take the bandsaw and cut this and this. Then I'll take this and drill it out with this size hole. Then I'll go to the next maybe 5 or 6 drill bits up. Keep on going until I get them all. And then once I get that done, I got to figure out another way, because I don't think I can get this in my 4-jaw chuck. I don't see it happening. So we may have to cut this out the old-fashioned way. Oh shit. A grinder, a jigsaw, a round grinder on your Dremel, a jigsaw, drill bit. You got to go and cut circles all the way around that, as close as you can get them without them going into the next hole, so that all you have is just a minute amount to break out of it. And you just do that all the way around it on the inside of that line, and then you take your die grinder and grind the rest of it, one section of it out big enough that you can get your jigsaw blade in it. Once you get your jigsaw blade in there, it'll be easy. Just cut all them little ears in between it. Once you get that done, you start filing it with a half round file, and you're done when you're done. So this will be for tomorrow. I'm going in tonight. This will be step number 1. So I think I lucked out by being able to turn the motor upside down, and it lined right up, right where I wanted it. So apparently where this pulley goes down on there like so, I'll bet you the motor, the axle, it wasn't very far from the wheel, about that far too. So I bet you any amount of money that was the adjustment it had. So anyway, that will end part 1 of the grizzly head, or what should I call this? Grizzly Power Z axis. So anyway, you guys have a good one. Later.